Good day, everyone. And once again, we are back together. I just thought let's just quickly look at this exercise as you guys are preparing for your exams. This is obviously based on analytical geometry. So if you haven't subscribed, just please make sure that you get yourself there. Just hit that subscribe button. And by the way, we are working towards 100,000 subscribers. Please make sure that you tell all your friends about this channel. All right. Okay, so let's get right into the exercise. I got this from the November 2021 paper. And yeah, it's very interesting. All right, let's go through it. So they say in the diagram, you've got A, which is minus 2 and 10, and B, which is K and K. You've got C, 4 and minus 2, which has the vertices of triangle ABC. They say line BC is produced to H. So what they're trying to tell you is that that's a straight line. Okay, that's going to be significant later. And they say it cuts the x-axis at E, which is 12 and 0. And AB and AC intersect the x-axis at F and G respectively. They say the angle of inclination of line AB is 81.87. So usually, of course, the information that is given will kind of lead you to the diagram. It's basically the same information that you have on the diagram. All right, now let's look at the first question. They say calculate the gradient of AB, of BE rather. So now if we look at the gradient of BE, if you don't mind, I'm just going to work onto the diagram itself. So I hope that you don't mind. So if I look at BE, you remember B, we don't have the coordinates of B, right? But in this case, what we do have is that it's a straight line. So let me use the coordinates of CE instead. So we know we're going to simply say, well, BE is the same as the gradient of CE. So we're simply going to say y2 minus y1. I hope this is clearly visible. Divided by x2 minus x1. But now I'm going to use the coordinates of CE, right? So y2, I'm going to use that 0 there. Okay, this one over there. So minus y1, which is minus 2. Okay, negative 2 divided by x2 is 12. Okay, minus x1, which is 4. And in this case, what you simply have there is positive 2 over 8, which is actually the same as 1 over 4. So that's the gradient there. All right, and then they say they're looking for the gradient of AB. But remember, for line AB, we are given this angle of inclination. So we can use the fact that we know that the gradient of AB will be equal to the tangent of 10 of the angle of elevation. And in this case, it's 81.87. Okay, right. Now, if we quickly have a look at it, I had done it here earlier. So all you simply do is just say 10 of 81.87. Okay, and there you've got 7. So it means that the gradient there is actually 7. All right, now moving swiftly along, they say determine the equation of BE. So remember, we already have the gradient, right? So I'm just going to do it over here, over on the left hand side, but we know that it's going to be y is equals to a quarter of x plus c. Now let's substitute one of the points that we know for line BE. And one of the points that we know, obviously, we can substitute either C or E. Let me just choose E. In this case, when y is 0, we know that x is 12. Okay. Plus C, let's get that value for C. Sorry, this is 1 over 4, not 1 over 2. In fact, let me just erase it quickly. Okay, so that is 1 over 4 times 12, which is 3, right? But when I take it to the other side, I get negative 3. So that will be, so it means that the equation is going to be a quarter of x minus 3. All right, so that is our equation. In this case, this is answering 3.2. Okay, right, I hope you're still okay with that. And then the next one, they say to us, calculate the coordinates of B where K is less than 0. Now, I want you to note B is actually on that line there, which is BE. So we can use the equation that we have just calculated or just obtained in this case for BE. And we say, well, we know that when X is K, Y is also K. So in this case, what it simply means is that let's substitute there the values of K and K. So if we say, well, K is equal to, so this is in answering 3.3.1. Okay. So K is equals to a quarter of K, right? So X is K and Y is K. That's minus 3. So if I take that, I've got two common two like terms in this case. That's K and quarter of K. If I take it to the other side, it becomes minus. So you'll have K minus 1 over 4K. That will give you 3 over 4K is equal to negative 3, right? So if you, trying to get rid of that, I'm going to multiply by the inverse, which is 4 over 3. But what I do on the left, I do on the right. So in this case, that cancels with that, and that cancels with that. So you'll have, so it means that K is minus 4. All right, I hope that that is still quite visible. Right, so we get the value of K to be equal to negative 4. Okay, and they did say that it is less than 0. So we know that's going to be negative 4 and negative 4. All right, now, quickly, so they say to us on the next one, calculate the size of A. Now, going back to our diagram, okay, so A is that angle over there, right? Now, I'm going to work with triangle AFG, right? I already have this angle inside here, but we can actually obtain this angle over here, which is angle G, if you want to call it that, in that triangle. So how do we do that? Okay, we can find the gradient of the line AG, right, or AC. So the gradient of AC, I think we had not obtained that as yet. So the gradient of AC, we would say, all right, that is y2 minus y1, so that's going to be 10 minus a negative 2 divided by x2, which is minus 2 minus 4. Okay, so that will give us, that's 12 divided by negative 6, and we know the gradient is negative 2. So that means in order for me to get this gradient, or rather this inclination angle there, I'm simply going to say, well, I know that the tangent of the angle of elevation is equal to the gradient, but my gradient is negative 2. So in order for me to get the angle, I'm just simply going to say the arctan of negative 2. And you'll see that obviously we'll get a negative angle, but I'm going to explain that. Okay, so I'm going to say shift 10 of negative 2. Okay, I get minus 63.43. Now, please, I want you to note, because we've got a, an angle of elevation there that is, or rather the gradient is negative, what it actually gives us, that angle there, minus 63.43, I believe, right, is actually this angle over here. Okay, so it means this angle is 63.43. Now, the reason why it came out as negative is that, remember, whenever we calculate the angle, we always measure the angle from the positive you know, x-axis, right, going anti-clockwise. But this time what it did is it measured this angle from the negative x-axis going going clockwise. So we're going the opposite direction, and so that's why it's negative. Alternatively, what you can do is when you get that negative angle there, you can actually add 180 to it, and what it will do is that it will give you this exterior angle here, right? But now, okay, let me show you method number one. We know now that this is 63.43, right? So I can use angles on a triangle and say, well, to get this angle, I'm simply going to say 180 minus 81.43, sorry, minus 81.87, okay, plus 64.43. Okay, sorry about that, little bit of a mess there. Okay, so that's 81.87 plus 81.87, okay, plus 64.43, and what I get there, let's see, so we'll just simply say that's 180 minus, in this case it's 81.87 plus 64.43. all right, and I get an angle of 33.7, so it means that the value of A is 33.7. Alternatively, remember I said you could have found this angle here, and obviously if you take 63.43, or you say 180 minus that, minus 63.43, what you get there is 116.57. But remember, we can now use, let me just use a different color there. Okay, so I can take this triangle here, okay, which is triangle AFG. And in this case, what you can do is you can use that as an exterior angle. Remember, the exterior angle of a triangle is equal to the sum of the opposite interior. So it means this angle plus that angle gives us that exterior angle there. And in that case, you can actually find angle A that way. Okay, right, and moving very swiftly along. They say find, in this case, the coordinates of the point of intersection in the diagonals, of the parallelogram ACES, where S is a point in the first quadrant. Now, going back to our diagram, yeah, we've actually made quite a mess of it. Okay, so let me just try to use a different color there. Sorry if it looks a bit messy. Obviously, this is still experimental for me. Okay, trying to use this method. So if we were to draw a parallelogram there, right, where we say, they did say that it's ACES. Where is E? Okay, so that is ACES. Sorry, actually, that's the parallelogram there. Okay, ACES. So it means that is point S over there, right? So they want the coordinates, or rather the intersection of the diagonals. Now remember that for a parallelogram, the diagonals actually bisect each other. So what I can do is I can find, in this case, the midpoint of the line AE. Okay, so the midpoint of the line AE, and in this case, that would give me the coordinates of the intersection of it. Now, the midpoint, obviously, so if I use my midpoint over there, So that would be, for x value, it will be 12 minus 2 over 2. So it's going to be, remember we always say x1 plus x2 over 2, and you've got y1 plus y2 over 2. Okay, right, so in this case, my midpoint in that case would be, so that's 12 minus 2 over 2, as well as 0 plus 10 over 2. Okay, so your coordinates of your midpoint, in this case 12 minus 2, that will give us 10, divided by 2, that will give us 5. So that point there will be x value 5, and as well as y value also will be 5. And by the way, those values did come out positive, both of them. It is in the first quadrant, so it does make sense. All right, now let's continue. So in this case, I've got the next point. Now they say to us another point T, which is P and P, where P is greater than 0. So it means that that must be in the first quadrant. Okay. They say it's plotted such that ET, so it means T does not, is a point that we do not know of. Okay, so they say ET, so T could be any random point, just for argument's sake there. So they say ET is equal to BE. Okay, so BE, all right, so that should be a point which is quite far off our diagram. They say it's 4 root 17, right? Now they say calculate the coordinates of T. Okay, now I want you to note in this case, we know the distance of we know the distance of ET, right? And we want the coordinates of T, right? So in this case, what I'm simply going to say is, let's just write down, so ET, in this case, we are given that it's 4 root 17, right? So that's 4 root 17. And now, what we can do is just to simply say, now note in this case, we don't know where that point is, that is point ET, but we know the distance of it, right? So we can use our distance formula and say, well, look, suppose that the point T, and note that T is P and P, meaning it's got a similar x value and a y value. So we're going to use our distance formula and say, well, we know that ET squared is equal to, now please, I want you to note, we say, well, that's x2 minus x1 squared plus y2 minus y1 all squared. So in this case, we know this is going to be 4 root 17, right? Now, for our x2, we are going to take the the coordinates of T, which is going to be P minus, for x1, remember we're saying we took ET, so we're going to take the values at E, right? So that's minus 12. So that's going to be P minus 12 squared plus, for our x2, y2 rather, it's going to be P minus y1. What's the value at y1? In this case, that was 0. Okay, right. Now, oh, sorry, I forgot to actually square this value over here. Okay, and what do we get? Okay, so I'm going to get P squared minus 24p plus 144 and plus P squared, and in this case that's going to be, so if I take 4 root 17 squared, okay, I'm not too sure what I'm doing here, 4 root 17. Yeah, there we go. Okay, and if we square that value, what we simply get is 272. So that gives us 272. Okay, so we've got p squared and p squared. That gives us 2p squared minus 24p. Okay, and if I take that value to the other side, what it gives us, we've got 144 minus 272. Okay, so we'll say minus, okay, and I get a value of 128. So that will be minus 128. And this gives us 0. Now note, what I can do here is that I can just simply divide both sides divide both sides by 2. So what I've got is p squared minus 12p minus 64. Okay, and this is equal to 0. Okay, let's see if we can factorize. What are the factors of 64 such that when I subtract them, okay, so let's see if we say, so we can get p and p. Factors of 64, okay, let's see. Yeah, I think it's 16 and 4, right? 16 and 4. And of course, this would be negative and that would be positive. And in this case, so it means that p is equal to 16 or p is equal to negative 4. Now, please remember, what they had said to us is that p must be greater than 0. So it means that this one will not be applicable. So in this case, our correct answer will be p is equals to 16. Right, so I hope that makes sense. Right, now they say to us, determine the equation of the circle with a center at E. Now remember, E had the coordinates or has the coordinates 12 and 0. So we already know the x value and the y value of the center. And then they say, and passes through B and T. Right? Now, let's go back to our structure. Okay? Now, remember, B is the point minus 4 and 4. So, if we could get, so T was the point that we calculated there. So, we didn't know the distance, right? Did we? ET. Oh, yeah, they said it passes through. Oh, yeah, remember, we already know the distance in this case. So ET, remember, we're given ET to be 4 root 17, right? So it means that we know also the radius in this case. That would be the value of the radius. And remember, for the equation of the circle, right, they did say we should write it in the form x minus a. Remember that a represents the x value of your center. Okay, the y value, b represents the y value of your center, and your r squared is obviously your radius. So this will be x minus a squared plus y minus a squared, which is equal to, now r squared in this case, we did say we know the value of r squared, right? Of r rather. So this is x minus, our x value is 12. Please remember to change sign when you take it inside this bracket here. It was a positive 12 over there, so it becomes negative when it goes there. Plus a is 0, so in this case you might as well just say y squared, or you can simply say y minus 0 squared, and this is equal to 4 root 17, remember, all squared. So it means it's going to be x minus 12, right, squared, plus y squared, which is equal to 272, which was the value that we obtained there. Okay, right, so that's the equation of our circle. All right, and then finally, they say determine the equation of the tangent to the circle at point B. Now, Remember when we want the equation of the tangent, right? So it means, just imagine in this case, I'm just going to zoom in into a diagram. Right, so there's our circle, there's the circumference of our circle. There, you can go all the way, right? So if we've got a tangent, let me just draw it in a blue color there. If I've got a tangent there, what do we know? We know that the gradient of line ET, or EB rather, will be perpendicular. This is what we call the 10 radius theorem, right? So in this case, at the point of tangency, what will happen? It means they'll be at 90 degrees to each other. Now I want you to please note, we can find the equation of or rather the gradient of BE. By the way, we already have done that. It's 1/4, right? So it means that the gradient, remember, if two lines are perpendicular, it means the product of their gradient must be equal to -1. So the gradient of AB multiplied by, not AB rather, the gradient of BE, okay? The gradient of BE multiplied by the gradient of our tangent must be equal to -1. Okay, right. Now, please, I want you to note, all that you simply do is just you change the sign and you invert the gradient of the other one. So it means that the gradient of our tangent in this case would simply be, instead of having 1/4, we'll have -4. It changes sign and you invert. Instead of 1/4, it becomes 4/1, which is actually equal to 4, right? So that's -4. So, and it passes through the points -4 and -4. So what we can simply do, that to find the equation, we can now simply write it as y is equal to -4x plus c, right? But we know that that tangent also passes the point -4 and -4. So we know when x is -4, y is -4. So this is going to be -4 plus c. And in this case, we're saying, okay, the -4 and -4 gives us 16, positive 16. We take it to the other side, becomes -16. So -4 minus 16 is equal to c. So our c value is equal to -20. So the equation of our tangent would simply be y is equal to -4x minus 20. All right. Ladies and gents, I hope that helped. You can go and look at that question once again from the DBE question paper from 2021. All right. Just make sure that you familiarize yourself, and really, this section, you can really score some free marks for yourself if you know what you are doing. Otherwise, I'll see you guys next time with another very short exercise to do together. All right, see you again next time. Don't forget to subscribe. Sharp, sharp.